used to do the same thing using Lambda expressions. So these functional features were introduced in Java version 8. So make sure you're up to date with your version of Java. I'm using version 10, okay? So make sure you have version 8 onwards to be able to type the code that I'm about to show you in this lecture. So what's a stream? Well, stream is basically, it's exactly what it sounds like. It's a pipeline that consists of a source and a few operations, and then finally a terminal operation. So there's 3 components to a stream. So here's a picture representation of what I just spoke about. So the source is collections, files, as well as data types such as ints, longs, and so on. And then you have these intermediate operations. And there are many intermediate operations, but these are just a few, such as filter, sort, and map. And then finally the terminal operation, which can return a void, or it can return a non-stream result. So it's important to understand that the intermediate operations, such as filter, sort, map, and you'll understand many more, these intermediate operations return a stream, okay? So you can call these over and over again, and it will just update the stream of data that we're working with. The terminal operation is the thing that actually terminates the stream and returns a result. So let's go into a bit more detail about intermediate operations. You can have 0 or more intermediate operations, right? They're not a must. You don't have to have intermediate operations. You can go directly from the source to the terminal operation. And in terms of intermediate operations, order matters. So if you want to filter data, you do that first and then you sort. If you have a really large data set, you don't want to be sorting that data set first and then getting the data. You want to first filter so that you reduce the amount of data that is needed to work within that stream, and then you sort it and map it and so on. We'll go over some of these examples. So another cool thing is for very large data sets, we can use something called parallel stream, right? And that enables multi-threading to perform operations to split the number of tasks and make your application faster. And with the advent of parallel streams, it's far easier to write the code to perform tasks on large data sets. This was all introduced in Java 8. So here are some examples of intermediate operations. There's many others, but here's just a few. If you want to filter, you can use the filter operation. You can distinct. You can skip certain rows, for example, within a file or within a set of data. And then there's, of course, sorted, which does exactly what it sounds like, right? So these are intermediate operations. They return, every one of these operations or functions returns the stream updated, okay? And you can have 0 or more of these methods or operations applied to the stream. Terminal operations are the thing that pretty much ends the stream. It terminates it. And there is a looping mechanism that we'll talk about in the code, and that is called for each, which applies the same function to each element within the list of data that we're working with. And collect is another function. It's a terminal function, of course, and that basically saves the elements into a collection. And there are some other operations that reduce the stream to a single summary element. So you can do you can get the mean, min, max, all of that stuff using summary statistics, count, and sum. All of these basically give a single value, and that is typically referred to as reducing the set of data to a single value. Or it could be no value. Terminal operations can also return void. So let's go into some examples. I've created a project called Lambda Practice. You should already have this from the previous lectures. And in the source folder, I created another package called streams.practical. And in here, I've got the app class that I've pulled up right here, okay? So another thing that I've added is this files folder. And if you expand it, there's 2 files within here, stock data CSV as well as Word file. You'll have this as part of the code that you download for this course. So make sure you've updated your code base with this project. So let's just briefly look at what these files contain. If you open up stock data CSV, it just has Apple, Facebook, Amazon. These are the ticker symbols. And then with a comma, it has the different prices. I just basically randomized these. I didn't think of any given numbers. I just randomly put these prices. So this doesn't emulate the stock market in any way. So this is a comma separated value file. And then we have a Word file, which just has random words, okay? So we're going to be using these files shortly. But what I want to do first is make sure that these files are included in this project, in the build path of this project. So if you right click and go to build path and you go to configure build path, you can add the files folder to this, all right? So just go to add folder and then select this files folder and hit OK, apply, and make sure that you can see this right here. Both of these files have been included. And so you should see both of these options here in the source. So click on apply and close, and the configuration is done. So now let's go over some of the code that we're going to need. So the first example, I've already typed it up here on a different screen. I'm going to paste it so that it's quick and easy to work with. We don't have to worry about typing this, and we'll save some time. I'm creating something called an int stream. Okay, and this is actually a new type within Java. Notice it's saying Java util stream. It comes from the stream package. So let's import that. And this is that thing. So we're creating an int stream, a set of integers from 1 to 10, okay, using the .range function. So this is the source. And then this is the terminal operation. We don't have any intermediate operations. We just have a terminal operation in this example. So this is going to print to the screen the X, which is supposed to represent each of these numbers, okay? So this for each is going to loop through the range 1 through 10, and it's going to print out those values. So if you right click, run as Java application, make sure you save this file, and this is the output right here. Now notice that it prints from 1 to 9. It doesn't print the number 10. And the reason for that is this range function is non-inclusive of the last value, okay? So it just takes from 1 to 9, and 10 is, is not part of the range. So that's pretty straightforward. Let's paste the next example. So here we have an integer stream with the skip intermediate operation. Okay, so we're creating a range between 1 to 10, and then we are skipping 5 elements. Okay, so notice it's saying skip 5 elements of the stream. And then for each of the results from this stream, we're actually printing them out. Okay, so understand that this right here is the source. This is the intermediate operation. So we're filtering, we're reducing the number of results that are involved in the stream. And then for each of those results, we are basically printing to the screen. So let's right click. Let's save this file first, run as Java application. And there we go. Notice it skips up to 5, and then we get 6, 7, 8, and 9. So again, the second argument to the range function is non-inclusive. So the original stream was from 1 to 9, and then using the skip, we were able to skip the first 5 elements, and so what's left is just from 6 to 9. Let's go over the next example. Here we have an integer stream with the sum terminal operation. So this is the source, and then this is the terminal operation, right? Well, we're not using an intermediate operation here. We just want to sum the range. And so we are storing that in a variable of type int. And so we can print that right here. So run as Java application. Want to save the file? Yes, we do. And there we go. We get the result as 10. Moving on, let's go to the next example. So here we have a list of data. Okay, so stream of is a function that you can use, and it belongs to the stream class. So let's import that. If you hover your mouse here, notice it's going to import stream. And so we can use stream of these 3 words. So this is the source, right? Then this is the intermediate operation. It sorts the values in the stream and returns a stream object. And then find first basically is the terminal operation, which basically picks out the first element in that sorted stream. The final line where it says if present basically is there to prevent null pointer exceptions, right? This is typically a setup when we're working with streams like this. We want to always have if present when we're utilizing some particular element within the stream. It could be null, so we want to make sure we protect against that. Run as Java application, and there we go, Africa. Let's keep moving forward. Let's go to the next example. Here I've got an array of items, right? These are just some random items that I created. And then we're doing a stream of these items. All right, so we're doing a stream of this array. And then now what we're going to do is we're going to filter each of those items that start with the letter T, like that. And so this is an intermediate operation, we're filtering it. And this is another intermediate operation where we're sorting it. And then finally, this is the terminal operation where we're where we're terminating the stream, where we iterate over each of the values in the given stream up to this point, and we print them out like that. So let's right click, run as Java application, and you'll notice that these are the three values that we see here. They all start with the letter T, and they are sorted. Okay, so let's go over the next example. So here we're doing an average of squares of an int array. So I'm creating a new int array, and I'm passing that to the arrays.stream method, okay? Hover your mouse on this and notice it's saying we want to import arrays. And so we have the ability to stream arrays like this. So this is a source of data, and now we're going to map it, which means that each of these values, 2, 4, 6, 8, and so on, each of these values is going to be mapped to this square. So the average right here is going to be computed on the square of these elements. So let's save this file, right click, run as Java application, and there we go, 44. So in this case, this is the terminal operation. And notice for all of the terminal operations, if you go to the documentation, it actually does say this is a terminal operation right here. So we're taking multiple elements and we're getting one value out of this. And then this if present method is just there to prevent null pointer exceptions, okay? It returns a value, otherwise it does nothing. So we don't want to print something that doesn't exist. So if there was nothing returned by this average function, then this line of code would, we wouldn't be printing anything, okay? So let's keep going. I'm going to move to the next example, and here we have a new way of creating a list. So you should already know this. Arrays.asList basically converts this list of things into a collection element, and that is of type ArrayList or just list in this case. And then we're going to use that list to stream it. All right, so this .stream method can be used for a collection of items, and then we map all of the elements, each of these elements, to the lowercase version of them. All right, so computer with C is capital, T is capital, B is capital for this. So we're going to lowercase all of those letters, and then we're going to filter and only get those letters in the stream that start with the letter lowercase c. And then we're going to sort it, and then we're going to print it, okay? So let's just do the imports here. I'm going to Control-Shift-O to bring in the imports from the list. And there we go. Now this should run properly. Let's run the code. And there we go. We get car and computer. So the next example is going to involve streaming files. So I showed you that we have two files here, stock data and Word files. So let's actually create a stream of one of these files. So here I'm doing files.lines, and then this is a new way of basically getting data of referencing opening a file, right? And then we are basically assigning it to a stream of elements. So let's just do a Command-Shift-O to bring in the import, and notice that this is going to throw an exception because it's involving file handling. So we can actually wrap this around in a try-catch block like this and put all the code within this try block, or let me do a Command-Z, or we can actually throw the exception in this method, the main method. So I'm just going to do that in this case. So let's just throw the exception right here so that all this code compiles. So using that lines variable, which is a stream of string elements, I could just do lines.sorted. I could sort each of those lines, each of those words, and then I can filter for those words that have a length greater than 6, okay? And then for each of them, I print the values. So let's run this application, and notice that these are all of the words that have a length greater than 6. So whiteboard, Samantha, Powerade, and so on. You can count all of these, and they all have a length greater than 6, as well as they are sorted. And towards the end, we want to make sure we close the stream. When we open a file like this, we need to close it. So that's why we have lines.close. This is very important. You can actually get rid of this line and forget to do this, and this will leave an open stream, and that can cause memory leaks in your application. So you always want to make sure you actually do lines.close whenever you're dealing with files. Can you think of a way to optimize this code? Well, we can actually filter first before sorting. If this was a very large file with millions of words, sorting them first would take some time, right? We're only interested in words that have a length greater than 6. So why don't we just filter those words out first, okay? So that we have lesser data to deal with. And then once we have that a smaller list of words, we can sort them, and this would perform a little better, okay? In this case, it doesn't really make a difference because the file is so small, but in large files, this can make a difference. Let's go over the next example. Here I've got a list of words, all right? And I'm getting them from the Word file that we just opened just a few moments ago. And then I'm filtering to see if the word contains the letters TH. Only in that case, we're going to collect those words. So what is collect? This is a terminal operation. This basically converts the list of words into, or the stream of words that we are interested in, into a collection. So notice using collect, we could do collectors.toList. So this basically gets the stream of data and converts it into a collections list element, okay? And so for each of those words, we could do a for each and print those values out. So Command-Shift-O to bring in the imports. I'm going to bring the list. And then let's run this code, and there we go. Let's keep moving. The next example is, let's try to open the stock data CSV file, right? This is the file that has the comma-separated values. And we're going to store that into a stream of strings, right? Each of them represents rows. So we do rows.map. So we take each of those words and we split them using x.split, right? There's a lambda expression. We're splitting on the comma. And then we filter for those lines that have more than 3 elements because we're splitting on the comma, so greater than 3 elements. And then we do a count, okay? So this count is the terminal operation. These two are intermediate operations. They both return streams of data. And so this is the actual terminal operation. This returns a single int. That is why all of this code right here, we're casting it to an int data type, and then we're assigning it to row count, all right? And here we're just printing the row count. And rows.close, we want to make sure that we close the file or the stream that is involving that file, okay? So let's Command-Shift-O to bring in that import for the stream, and then let's right-click, run as Java application, and see what the row count is. And notice it's saying 3 good rows. So 3 rows have a length greater than 3, meaning they have 4 or more elements per row, separated by commas. So we went over a bunch of examples up to this point. Let's go over one last one. So here we're opening that same stock data CSV file. And so we're mapping each line of the file to the splitting of commas. So to break this down a little further, this X represents the line, the entire line as a text. And then this basically splits that line on commas and treats the whole line as an array, okay? Very important to keep that in mind. That's what this is doing. This is splitting the text into an array. It's mapping it from a string to an array that is split on the commas. And so once we have that updated stream, we're going to filter each of those array elements, and we're going to be only interested in those arrays that are of length greater than 3. That's what this is doing. And then we're going to filter further and say that the integers, we're going to parse them using integer.parseInt, because after splitting them, they're still text. So we need to turn that into the actual number, integer equivalent. So the number at index position 1 dot trim, to make sure we eliminate any white space. If that's greater than 15, that's the thing that's involved in the stream, okay? Everything else is filtered out. And so up to this point, we've got an updated stream of data that falls within these conditions. And now we can for each over all of the remaining stream elements, and we can print the different values of each of those lines, okay? And here we close the stream. So let me run this, and boom, there you go. Notice Apple and Amazon both have values. Their first value is greater than 15. Notice if you read those numbers, they're greater than 15. So this code is working as expected. All right, so I went over a bunch of examples here. Hopefully you see the value that streams provide. If you had to do this using the older versions of Java, you'd need a lot more code, but using Lambda expressions and streams, this makes working with collections and streams of data much, much easier and faster and less lines of code. So with that being said, let me wrap it up. Thanks for watching. I'll see you in another lecture.